everybody, this is a video to demonstrate what happens when there is a current that is flowing in a wire and the wire is in a magnetic field. Okay, so I have here a really long length of wire which is probably about 2 meters long, and it's connected to the terminals of a DC supply. So one end is connected to the positive, the other end is connected to the negative. Current flows out of the positive and then goes into the negative. Now, the poles of the magnet have between them a uniform magnetic field, and the magnetic field goes, it's a direction in which a north pole would move, so these are horizontal lines. Okay, now when I turn the power on, the charges are going to flow. Now, these moving charges in a magnetic field, and these charges are perpendicular to the direction of the field, they are going to experience a force. This force is a maximum when the direction in which the current moves, or the direction in which the charges flow, is at right angles to the magnetic field. And this force is going to cause the wire itself to move. So watch what happens. So you saw the wire moving, it jumped out. Okay, now in order to, so the size of the force, this is a magnetic force that is given by F equals BIL. B is called flux density, or it's a magnetic field strength. I is the size of the current, and L is the length of the wire in the field. So it's just this little bit length, it's not the whole length. Okay, and how do you get current? Current, if you know the voltage and the resistance of the wire, you can do V over R to get the size of the current. Now we use the right hand slap rule to get the direction of the current, the field, and the direction of the force, and therefore the movement. So if you notice, the wire actually jumped up, outwards, so the palm of my hand is facing upwards. The thumb indicates the direction in which a positive charge will move, which is the direction of the current, and my current was flowing this way, so that's the direction of the current. The fingers is the direction of the magnetic field, and that's the direction in which a positive charge will move. And that's the direction in which the north pole would move. So field lines go from the north to the south. So that's the way my fingers are pointing. Okay, and that's what we use to determine the direction in which the wire would move in case when there's a current flowing through. Now, if I had placed the wire this way, it's parallel to the magnetic field, so nothing's going to happen. The force they experience is going to be zero. The direction of the wire, and therefore the current which flows, has to be perpendicular